Hi, a very good morning to our lecturer, Prof. Maria Sitiawa. So, introduce myself. My name is David Telungwe, CE190146. So, this is our full report segment for Group 3, and this is my group member, Tan Kawang Abdul Hakim.
Assalamualaikum and salam sejahtera. My name is Abdul Hakim. So I will explain for the introduction. As for the introduction, what is active filters? So active filters are a group of electronic filters that utilize active components like an amplifier for their functioning. And op-amps are used to allow easily to make many types of active filters. An amplifier stops the load's impedance from affecting the filter characteristic. And a filter is a device that allows some frequencies or frequency range to pass while blocking others from doing so. And a band pass filter is a device that passes frequencies within a given range while rejecting frequencies outside the range. And it is made by cascading a high pass filter and a low pass filter. A band pass filter can be considered as a second order filter because they have two reactive components, which is the capacitor. And as for the theory, we built the circuit to complete the objective, which was to create a fourth order bandpass active filter using an op-amp. The circuit is essentially designed using four op-amps, and the first two op-amps are used to create a high-pass filter. A low-pass filter is the other of two op-amps filter. That's all. Thank you.
So, proceed to my part. I'm doing part presentation about theory evaluation and circuit simulation, result analysis and discussion. For theory and calculation, we need to build circuit complete the objective in this assignment. We need to get four order bandpass activity using OM amplifiers. So we need to design a four operation. First two is using the high pass and low pass is another two. So given for group 3, mid gain is 10 dB, low cut off is 20 kHz, high cut off is 90 kHz. For first calculation, we need to find the dB factor of the F, where the F1 we get is 0.765 second, and for the AV01 equal to AV03 equal to 2.235. So for the DF2 equal to 1.84x. So to get the, after doing the calculation, we get the AV02 equal to AV04 equal to 1.152. So next we need to assume the value of RA equal to RA1 equal to 10 kHz. So for the RF1 we get 12.35 kHz, and for the RF2 equal to 1.52 kHz. For HPE we use the low cutoff, which is 20 kHz, and we need to assume the C equal to C1 equal to C2 is equal to 0.02 microfarad, and then we, after doing the using this formula, we get the R1 and R2 equal to 0.0362 kHz. So next we need to assume that C3 equal to C4 equal to 0.02 microfarad, and for the R3 equal to R4 we get the 0.3979 kHz kilo ohm. For the LPF we use the high cutoff, which is 90 kHz, and we need to assume the C 5 and 6 is equal to 0.022 microfarad, and we get the R5 and 6 0.0804 kilo ohm. For the C7 and C8 we assume is 0.002 microfarad, and we get the R7 and R8 is 3.9789 kHz. For the mid gain we follow it, then we proceed to this part, which is pass band gain 20 log 10, we get 20 dB. For the center frequency we use this square root high cut off time low cut off, 90 times 20, which is equal to 42.464 kHz. For the center frequency, for the Megwitch high cut off and this low cutoff, we get answer 70 kilohertz. So proceed to part 4, which is circuit diagram, where we use the multi-sim simulation. This is the multi-sim multiplication. We need to get the 4 of ohm amplifier, and this is the function gen, and we need to, after we doing the calculation, we need to apply it to the R1 and 2, 3 R4 R5 R7 R8, and the assumed value of seed. Before this, we have the assumed value, so we put it in here, where we can adjust the value in here. We can adjust it and click OK. So after that, we save all the simulation, save all the value component that we correct according to the calculation. So we run the simulation, and we get this simulation result, and we add to show the question. For the question 1 is show the low cutoff, and the question number 2 is show the high cutoff. So we adjust it. This is for frequency, we need to adjust to 9, and the circle frequency adjust to wait, okay, 1.2 dB. So I adjust it to 1.2 dB, and almost the same. So the low cutoff of this we add the data level at the cursor. So the low cutoff we get from this simulation is 9.6, and from the theory that given for group 3 is 20 kHz, so it's not so far. And for the high cutoff they given in group 3 is 90 kHz, but we get in simulation is 81.532 kHz. So for the mid gain, we get is around 16.2 103 is the mid gain. Is the mid gain we get from it, which is almost where the given group is 10, but we get the 16.213 dB for the mid gain. So this is our circuit simulation, and proceed to the output and phase diagram and the phase frequency. So proceed to analysis and discussion, where our findings show that the simulation results are nearly identical to the reported value, where this is our theoretical value and this is our simulation value from the circuit that we have run just now. So based on the chart above, the low and high cut frequency were previously set, and because we assume that the output power lower to the half of the original value at the cutoff. So because we convert this difference to dB and find the maximum output power drop by 3 dB, the value of mid gain must be negative by 3 dB. So there are some discrepancy between the calculation and the multi-sim software. The supplement yielded positive result. So proceed to conclusion part.
My name is Tan Kao Wang, and I will explain about the conclusion of the project. As a result of the assignment, we may conclude that our simulation and calculation are valid, even though there are a few differences between simulation and calculation. As a result, the value of the resistor and capacitor has a significant impact on the frequency and gain. We were to identify the principle of low-pass active filter and high-pass active filter in this assignment. We also achieved another goal, which is to apply the calculation to low-pass and high-pass frequency cutoff, bandwidth, and center frequency. Among other things, Finally, we can learn how to use NI mutism 4.0 with a first order active filter in mutism. Thanks.